So, first thing first, we're going to actually go to a GeoGebra activity in which we look at the unit circle and how it relates to the sine, cosine, and tangent of things. Okay, let's try that again. So this GeoGebra worksheet or activity or applet has a unit circle. And what we're going to do is we're going to work our way around that unit circle, and we're going to figure out what's happening to these values as we work our way around. So now remember, with an ordered pair x, y, which one is what does x stand for? The cosine of our theta, okay? And the y stands for the sine of theta, okay? So when I move this guy back and I turn the sine wave on, what this is going to do is it's going to plot, as we go from 0 to 2 pi, all of the y values, okay? Not doing anything with the x, it's just the y's because we're graphing the sine, okay? So we know that the sine of 0, since it's the y value, is 0. So this little x is starting here, okay? What happens when we get to the sine of 30? What are we going to get? Sine of 30 is 1/2, so we'll have 0.5, and when we get to the sine of 60, square root of 3 over 2, whatever that is a decimal, right? And then when we get up here to 1, or to 90 degrees, the sine of 90 is going to be 1, right? So watch what happens. So we're working our way around, and we're tracing, and now we're at 12 degrees, and it's working its way up. Trace some more. And then we get to the top, and at 90 degrees, or at pi over 2, we're at 1. Okay? And then we keep going, and it starts turning around and going back, right? So at 120 degrees, we'll be at the square root of 3 over 2. At 135 degrees, we'll be at square root of 2 over 2, right? And then when we get to 180 degrees, we're back to 0. So far it's kind of made what looks like a parabola, doesn't it? Okay, now we keep going, and it gets to go below the x-axis, doesn't it? Because in the third quadrant and in the fourth quadrant, the sign is negative, isn't it? So we get down here, and we hit our minimum value, our absolute min, when we're at, can't quite get there, 270 degrees, right? Okay, and then it turns around, and it comes back, and when we're at 360, we're back to 0. So that's what the sine of x looks like. Does that make sense? Okay, we're restricted between 0 and 1, or 0 and positive 1 and negative 1, basically, and it's just going to work its way around and trace like so. So if I turn the sine wave on now, that's what it looks like when we plot all the points, not just the angles that we happen to have had. Make sense? All right, so let's look at the cosine. So we're back here at 0 degrees, and now we want to plot the cosine. Okay, so when we start at 0, 0, the cosine is always when we start at 0, 1, 1, 0, the cosine is always the x value, right? So at 0 degrees, the x value here is 1, so our little dot's going to start tracing from up here. Okay, so now we start moving, and the values fall, right? And when we get to 90 degrees, the cosine of 90 is 0, isn't it? And then we keep going, and we get in the second quadrant, and cosine is negative. When we get down here to 180, the cosine is going to hit its absolute min of negative 1. And then we keep going, we get to 270, and it's back to 0. And finally, when we get to 360, or 2 pi, it's back to the top. Make sense? So they're just the x values being plotted now as we work our way around. And that's what the cosine looks like. Okay. Now, what's the tangent going to look like? Tangent's the sine over the cosine, right? Okay. We have some special values for tangent. What did we notice about that that was different from the sine and the cosine? Let's trace it and find out. So I'm going to turn the tangent on. This one's going to be red now. And we're going to start at 0 degrees. What was the tangent of 0? Sine over cosine. 0 over 1 is 0, okay? And then what's going to happen as we work our way around? Well, at 30 degrees, we'll have something like this 1/2 divided by the square root of 3 over 2, right? So when we flip that, we're going to have 1/2 times 2 over the square root of 3, so it's like 1 over the square root of 3 or square root of 3 over 3. Okay, we get to 45 and we're up at 1, and then when we go to 90, what happens? Undefined. Can't get there, right? Because the tangent of anything divided by 0 is undefined. So then we keep going, and look what happens. Comes our little red guy. It shoots up to the top again, right? And then we keep going, and it looks like that. So here's the tangent graph. Okay? So what are these lines, these vertical lines? Vertical asymptotes, because there are places where it's undefined, where it can't be. Okay? So it shoots up and tries to approach it, but never can reach it, never can touch it. And then same thing, it ends high, so it starts low and works its way up. Okay? All right, so that's a little prelim of what we're going to be working with. And we'll come back to our presentation here and actually start graphing these. So first of all, I need to talk to you about the anatomy of a sine curve. When we want to know how long it takes to get one full cycle from the beginning to the end before we start to repeat, we're talking about the period of that function. And in this case, before the sine, one full cycle is from 0 to 2 pi. Does that make sense? So the period of a sine wave is 2 pi. The other piece to a sine wave is called the amplitude, that I want you to be aware of for now. And the amplitude is the distance from the center line to its maximum value, or from the distance from the center line to its minimum value. Okay? Or half of the max and min combined. So far, so good? Okay? So this has an amplitude of how much? 1. Okay? So the sine wave has an amplitude of 1 when it's in its most pristine basic form, in its parent function. Okay? So we're going to start by talking about y equals the sine of x. And we're going to do this in radian measure. So when we see pi over 4 is equivalent to what degree? 45. Anytime we see a 4 in the denominator, we know it's a 45, right? What is the sine of pi over 4? Root 2 over 2, which is about equal to 0.7 for our purposes, okay, since we're graphing and we can't be more accurate than that. All right, sine of pi over 2. So what's the sine of pi over 2? Okay, at pi over 2, we're up here, right? That's the ordered pair 0 over 1 up, right? The y value is 1. So the sine of pi over 2 is 1. The sine of 3 pi over 4, got another 45-degree angle here, right? Again, it's going to be root 2 over 2, right? But we're going to call it 0.7 for now because we're graphing. And in the second quadrant, the sign is positive or negative? Positive, okay? Now, pi. When we're over here at pi, the ordered pair is negative 1, 0. So what's the sign? 0. The y value is 0. 5 pi over 4, 45 degree in the third quadrant. A negative 0.7. About. 3 pi over 2. Negative 1, right? Because we're 0 over and 1 down, and the y value is negative 1. 7 pi over 4. 45 degrees in the fourth quadrant. Positive or negative? In the fourth quadrant, everyone, sine, tangent, cosine, so negative 0.7 again. And then at 2 pi, 0. Y value will be 0. Okay? So when we're plotting this at, we didn't actually, remember 2 pi is the same as 0, right? So at 0, we're at 0. Okay? At pi over 4, which is halfway between 0 and pi over 2, we're going to be 0.7 up. Okay, so we'll move 0.7. And then at pi over 2, we're going to be at 1. At 3 pi over 4, we'll be at 0.7 again. At pi, we'll be at 0. At 5 pi over 4, halfway between pi and 3 pi over 2, we'll be at negative 0.7. At 3 pi over 2, we're at negative 1. And at 7 pi over 4, we'll be at about negative 0.7. And then at 2 pi, we're at 0 again. Okay, so now trace those dots. And you've got your sine wave. Okay? That's one period between 0 and 2 pi. Okay? Now, let's make sure we keep going. We'll do the back portion of it. It just keeps repeating, right? So the easy way to do this then is to say, hey, I know that at pi over 2 I was at 1, so at negative pi over 2 I'll be at negative 1. At pi I was at 0, so negative pi I'll be at 0. 3 pi over 2, a negative 3 pi over 2 I'll be at a positive 1, and a negative 2 pi I'll be back at 0 again. And away we go. So when you're graphing sine, remember that it always starts at 0, 0, 0. And then it goes high, then back to the middle, then low, then back to the middle, and keeps going. All right, so what's the domain of the sine of x? Negative infinity to positive infinity. All real numbers. Okay? What is its amplitude? 1. From the center line to the top, its highest value is 1. Where are its zeros? 1 at 0, and there's also 1 at pi and 2 pi and negative pi, right? So when we write our zeros down, we're going to say 0 plus pi times an integer. And we could just take away pi times an integer as well, but those integers could be positive or negative. What's its absolute maximum value? 1. The highest it ever gets to be is 1. What's its lowest minimum value? And then what's the range? Negative 1 to 1. Do I need rounded parentheses or squared off parentheses? Brackets. Because it can touch negative 1 and it can touch positive 1. What questions do you have about this one? All right, you're going to get familiar with it, intimately familiar with it, to where you can just quickly sketch it without having to think about what points there are. To get the period, we just want to know how long did it take to complete one cycle. So here's one cycle between here and here before it starts to repeat again. So it's a total of 2 pi for its period. Okay. Any other questions about this one? All right, so next we're going to talk about the cosine next. Okay, so we had GeoGebra sketch it, but we're going to sketch it next. So let's think about pi over 4. What is the cosine of pi over 4? Root 2 over 2, just like sine was, right? And that was about 0.7. So square root of 2 over 2. For rounding purposes, we're just going to call it 0.7. Okay, how about pi over 2? Is it going to be 1 or 0? It's going to be 0 because it's the x value, right? So we're going to have a 0 of that 0, 1 coordinate. Okay, how about 3 pi over 4? Root 2 over 2, but negative this time, right? Because we're in the second quadrant and the cosine is negative there. So it's about equal to negative 0.7. How about pi? Negative 1. Okay, what about at 5 pi over 4? Negative 0.7. 3 pi over 2? That's our 0. And then 7 pi over 4? Positive 0.7. We're in the fourth quadrant now, and cosine's positive there. And then finally at 2 pi? 1. And 2 pi is the same as 0. So we're going to start out at 0. And when x is 0, the cosine of 0 is 1. Okay. Then we're at pi over 4, which is halfway between 0 and pi over 2. We'll be at 0.7. And then at pi over 2, we're at 0. And at 3 pi over 4, halfway between pi over 2 and pi, we'll be at negative 0.7. And then at pi, we'll be at negative 1. 5 pi over 4, negative 0.7. 3 pi over 2 is back to 0. And then 0.7 again. And then finally up high. So when you think about the cosine is starting high. At 0, he's all the way up at 1. And he ends high. Whereas sine started in the middle and ended in the middle. Okay. Now we just do the same thing going backwards. At pi over 2, negative pi over 2 will have the same value. Negative pi will be a negative 1. A positive 3 pi over 2 will be the same. And a positive 2 pi will be up here at 1. And we draw the rest of our cosine wave. So what's the domain of the cosine? So the range is going to be from negative 1 to 1, because those are the y values. That's the max and min it gets to be. But the domain is going to be negative infinity to infinity, all real numbers. We can plug in any values for x, any angle measure, and we'll still get a value for y. Nothing is undefined here. Amplitude. Good. 1. And now our zeros. Let's think about where our zeros are. They're multiples of we have a pi over 2, right? And then another 3 pi over 2, right? But it's not completely multiples of pi over 2. It's going to be pi over 2 plus every pi more, right? So it's going to be pi over 2 plus pi n. Every pi we get a new one. Okay? What's our absolute max? 1. Absolute min? Negative 1. And what's the period? 2 pi again. It takes 2 pi to get one full complete cycle. So far so good? What questions do you have about cosine? Okay, they look the same, don't they? It's just that sine starts at 0, 0, and goes high and then low and back to the middle. Cosine starts at 1 and goes low and then comes back up and touches at the top. Okay? All right, here comes the next one, which is the cosecant. Because the cosecant is the reciprocal of sine, all we're going to do is take those values that we had for the sine and we're going to flip them. Okay? So I'm going to save myself some writing. But what's going to happen when we have the cosecant at an undefined state? What do you think we'll see? What happened before when we had things that were undefined? We had to have asymptotes, right? So everywhere the cosecant is undefined, we're going to see asymptotes, okay? So for the cosecant, let's think about what the sine was at pi over 4. Square root of 2 over 2, right? Okay, square root of 2 over 2 flipped will be just plain old square root of 2, won't it? Okay, what's the square root of 2 as a decimal? 1.4. Okay, so this is going to be about equal to 1.4. Okay, now the sine of pi over 2 was 1. So when we flip that, we're going to get 1. The sine, or the cosecant then of 3 pi over 4, still in the second quadrant, we're still going to get a 1.4 square root of 2, right? But what happens when the sine was pi? We had a 0, right? So when we take 1 over 0, we're going to get undefined. Okay, 5 pi over 4, negative 1.4, because now we're in the third quadrant and we have a negative value for the sine, and therefore a negative value for the cosecant. 3 pi over 2, negative 1. 7 pi over 4, negative 1.4. We're getting in the fourth quadrant now, and cosecant is still negative. And then finally at 2 pi, thank you. What happens at 2 pi? Undefined again, isn't it? Not possible, empty set. Okay, now here's my hint. Anytime that you're graphing the cosecant, always graph the sine at first, but do it in a dash light format, like, you know, a ghost kind of format, so that you don't really confuse yourself. Okay, so remind me, how did the sine look again? Started at 0, and it went up, and then down, and then down, and then back up, right? Okay, so let's dash that just lightly, faintly, so that we can see where it's going, and we're going to use that as a guide. And then here we have to go down, mid, up, down. Okay, so we've got our sine wave as a pattern. And now what we want to do is put in our asymptotes. So where is the cosecant undefined? Pi and 2 pi, okay? So at pi, we're going to draw an asymptote. At 2 pi, we're going to draw an asymptote. Yep, we're going to take it back, because 2 pi and 0 are the same, aren't they? And then negative pi and negative 2 pi. Anywhere we have a 0 for the sine is going to make the cosecant undefined. Okay, now let's plot some of those points. When we're at pi over 4, halfway between 0 and pi over 2, we're 1.4 up. And when we're at pi over 2, we're at 1. And then when we're at 3 pi over 4, halfway between pi over 2 and pi, we're going to be 1.4 up. And at pi, we're undefined, right? And so keep going here. At 5 pi over 4, we're at negative 1.4. So halfway between pi and 3 pi over 2, we're at negative 1.4. And then at 3 pi over 2 will be at negative 1. And then at 7 pi over 4 will be at negative 1.4 again. So remember, it's trying to approach these asymptotes and never touch them. So we get something that looks like a parabola up here, right? And then an upside down parabola or reflected parabola down here. And then we do the same thing on the opposite side. It's going to be flipped, yep, upside down first, right side up. sense? Do you see why having that pattern, that sine wave there, is going to be helpful? Because it kind of gives you a guide to know what's going to happen here. All right, domain. Now we can't be all real numbers, can we? So where do we have our asymptotes? Multiples of pi, don't we? Okay. So x not equal to pi times n or n times pi. Is there an amplitude? Nope. Do we have any zeros? Nope. Now let's talk about a relative min or a relative max. Okay. Relative is min or max is a place where they hit a maximum or a minimum value, but it's not necessarily the overall absolute minimum or maximum value. Okay. So does everyone see that we would have a relative max here at negative pi over 2? Okay. Where else? 3 pi over 2, right? So negative pi over 2, or you could say, 3 pi over 2, either one, plus, and this is every how often? Every 2 pi, right? Or every, is it pi or 2 pi? Pi over 2. If we take away 2 pi, that would be taking away 4 pi over 2, right? And that would get us a negative pi over 2. So it's every 2 pi that we get a relative max. Okay? So 3 pi over 2 plus 2 pi n. Or you could have said negative pi over 2 plus 2 pi n. Same thing. How about a relative min? Where's one of those? Yep. Yep, pi over 2 plus another 2 pi n. Okay? Or negative 3 pi over 2 plus 2 pi n. Okay? What's our range? Very good. So we start with negative infinity, always open parentheses for negative infinity. The biggest we get to be is a negative 1, and then we have a gap, don't we? And so we can actually be negative 1, so we want a squared bracket. And then we have a gap that we can't be anything between 1 and negative 1, right? We can start in again at 1. So square bracket, positive 1, positive infinity. And what's our period on this guy? 2 pi again. So you see that we get a full curve or what have you over the course of 2 pi. Okay? Questions on this one? Yeah, we should probably do asymptotes too. I forgot to put that on there. So where are your asymptotes going to be? Yep, multiples of pi. So asymptotes is going to be pi n. Okay, so 0 times pi, 1 times pi, 2 times pi, negative 1 times pi. Okay, make sense? All right, next one. So let's think about how the secant and the cosecant or cosine are related. The secant is the reciprocal of cosine, right? So everywhere that we had a 0 for cosine is going to be an asymptote or an undefined value for the cosecant. For the secant, I keep saying it wrong. Sorry. So let me go to the next slide here and we'll put our numbers in. All right, so with the secant, 1 over the cosine was what at pi over 4? Root 2 over 2. So the secant is going to be 1 over root 2, or the square root of 2, and that's going to be about equal to 1.4. Okay, what about at pi over 2? It was 0, so it's undefined. Very good. cosine was 0, so the secant's undefined. 3 pi over 4. Negative 1.4. Pi. That's a 0. 5 pi over 4. 3 pi over 2. And then 7 pi over 4. Positive now because we're in the fourth quadrant. Cosine and secant are positive there. And then 2 pi. 0. So we're going to, not 0, it should be 1 here, right? Because the cosine at 2 pi was 1, so that 1 over 1 is going to be 1. All right, so again, always, always, always hint, sketch your cosine first. Okay, you'll get really good at making sines and cosines. So we're going to start where with cosine? Yep, going to start at 0. Yep. And we're going to start high for the cosine, right? And then we go down, down, middle, top, right? And then backwards, over here, so we go middle, down, middle, high. Pi should be negative 1, yes, because the cosine of pi was negative 1. Thank you for catching that. Okay. We changed the pi to negative 1. Okay. So now we sketch our cosine just with a dashed line, a dotted line, so that we're using it as a guide. Okay. And now put in your asymptotes, right? So we should have asymptotes at pi over 2 and at 3 pi over 2. And it's every pi, so we're going to skip over and go to negative pi over 2 and negative 3 pi over 2. And now we plot our points. So when we were at pi over 4, we're at 1.4. Halfway between 0 and pi over 2, we're at 1.4. And at pi over 2, we're undefined. At 3 pi over 4, we're at a negative 1.4. And then at a negative pi, or positive pi, we're at a negative 1. And then at a 5 pi over 4, we're at a negative 1.4. And then we're undefined. And then over at 7 pi over 4, we're going to be at 1.4. And then at 2 pi, we're going to be at 1. Okay? And at 2 pi, it's the same as 0, so we'll also be at 1 here. And then we repeat the pattern. So we're going up. On the bottom, we come and turn around. Make our turn. Looks just like the cosecant. It's shifted, isn't it? Just move to the left. Actually moved, yeah, to the left. Pi over 2. All right, domain. Can't be pi over 2, can't be negative pi over 2, right? And we can't be 3 pi over 2. So what is it? Yep. Plus pi n, right? Because pi over 2 times 2 would be a pi, and we can be a pi. It's just multiples of pi from there that we can't go. Amplitude, is there one? Bless you. Nope. How about zeros? Nope. Relative max. Got relative maxes at a negative pi and a pi, right? So these are multiples of pi. Okay, relative mins, negative 2 pi, 0, positive 2 pi, so 2 pi n. Okay, what's our range? Negative infinity to negative 1, and then 1 to infinity. I don't like this one. We did something wrong here. It should be actually 2 pi plus 2 pi n, right? We're at pi, and then 2 pi away. Yeah, so this is going to be relative max is going to be pi plus 2 pi n. Anyone see why? We get a max every time, every 2 pi away from pi. Okay, starting at the negative pi or this pi, every 2 pi we get a new one. So what's our period? 2 pi, just like it was with the other three. And then I'm missing asymptotes, right? So where are our asymptotes at? Asymptotes are at pi over 2 times n, right? Okay. So far so good? I think it's good to get all the parent functions out of the way to understand kind of what they're looking like, and then we're going to work with them. Okay? Let's get a feel for them. All right. Tangent and cotangent. Okay? So we saw what tangent looked like a little while ago. Let's think about how this is going to work. So tangent of pi over 4. Tangent of 45 is 1. Okay? Because it's the sine over the cosine, square root of 2 over 2 over square root of 2 over 2. Plain old 1. Okay? What happens at pi over 2? Okay? Are we 0 or are we 1? I'm sorry, 0 or are we undefined? So sine over cosine. So the sine of pi over 2 we're up here, and we're at 0, 1. Sine is the y, cosine's the x, right? So this is going to be the undefined one. Okay? At 3 pi over 4, negative 1, because we're in the second quadrant. Tangent's negative there. What about pi? 0. 5 pi over 4. Positive 1 this time because we're in the third quadrant and tangent's positive. And then 3 pi over 2. Undefined again. 7 pi over 4. And 2 pi. 0. And 2 pi is going to be the same as 0. So we know we'll be at 0 in both 2 pi and 0. Okay. So let's put our asymptotes in there. We have asymptotes at pi over 2 and 3 pi over 2. And so therefore, it's every pi that we're having a new asymptote. We're going to put one at negative pi over 2 pi, or negative pi over 2 and negative 3 pi over 2. And let's plot our points. At pi over 4, halfway between 0 and pi over 2, we're at 1. And then at 3 pi over 4, we'll be at negative 1. So halfway between pi over 2 and pi. And then at pi, we're at 0. And at 5 pi over 4, we'll be up here at 1. And then at 7 pi over 4, we're down here at negative 1. So it's doing something like this. It's going to continue on in like manner, right? Make sense? What's our domain? Good. Well, pi over 2. Now, pi over 2 times 2 would get us a pi. We're okay with a pi, right? Just not pi over 2. So it's every pi n from there. So plus pi n. Multiples of pi after that. Do we have an amplitude? Nope. Zeros? We're at. Lots of them, right? Negative 2 pi, negative pi, 0, pi, 2 pi. Yep, and pi. What's our range? Everything, right? We can have all values of y. How often do we have a repeat of the graph? In 0 to 2 pi, we actually get every pi, right? Because in 0 to 2 pi, we actually get 2 graphs, don't we? So we only need pi. This is the unique one. Okay, tangent, cotangent are the oddballs. Their period is every pi. And asymptotes, when do they occur? Pi over 2, right? And so pi over 2 plus pi n or n pi. Okay. Last one. Ready for it? Or do you have questions about tangent? All right, here comes cotangent. So cotangent is nothing more than the reciprocal of tangent, right? So everywhere that we had asymptotes now, we'll have zeros, and everywhere we had zeros, we'll have asymptotes. Okay? So the cotangent of pi over 4, cotangent of pi over 2, cotangent of 3 pi over 4, cotangent of pi, cotangent of 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So we'll be undefined at 2 pi, and we'll be undefined at 0. Asymptotes there. And then also on pi. And negative pi. And negative 2 pi. So far, so good? All right, let's plot those points. Pi over 4, we're 1. At pi over 2, we're 0. At pi over 3 pi over 4, we're at negative 1. At 5 pi over 4, we're at a positive 1. At 3 pi over 2, we're at 0. And at 7 pi over 4, we're at a negative 1. It kind of looks like a reflection across those, the lines where the zeros are, doesn't it? Missed my point, but trying to do my best. All right, so domain. So 2 pi, 1 pi, 0 pi, can't be n pi. Pi n, either way. Amplitude? Zeros. Oop, we do have zeros. These are zeros. Pi over 2. Yep, pi over 2n. Pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2. Range. All reals. Period. Just plain old pi, just like tangent, right? Those two are the oddballs. Asymptotes. Pi n. Okay. All right. Assignment for today is going to be to just practice this. Do this one more time for me. Okay.